Hello, my name is Jenna Van Sickle, and I am here to talk to you today about doing research in mathematics education for your senior project. My position at Cleveland State University is as a faculty member in the mathematics department, and I have a faculty position in mathematics education. My contact information is here if you would like to get in touch with me. My background is that I started with an undergraduate degree in mathematics from Valparaiso University in Indiana. When I was there, I got a full mathematics major, but in addition to that, I also did a complementary major in secondary education. It was always my intention to be a mathematics teacher, but I also kind of wanted to do something with pure mathematics, and I toyed with that idea a lot as I was in my undergraduate studies. I did a number of things to see if I wanted to do that. One of the things that I did was something I would highly recommend to you if you get the opportunity, which is an REU. That's a research experience for undergraduates. You can apply for these. Usually you would do one either in the summer that you are a rising junior or a rising senior, and they're a really great experience. They're funded by the NSF and they're all over the country. You can go for usually a 6-week stay at a university, and you do a research project with math majors from all over the country. It's great fun. You meet people who are equally interested in math as you, sometimes people who are much more interested in math than you. You play fun games with them and hang out with them and make lifelong friends in many cases. And I did an REU at Lafayette College in Easton, Pennsylvania. It was an excellent experience. I made friends for life, and the mentor that I worked with there is somebody that I still am in very close contact with. And that was an excellent experience. I also did something called the MASS program at Penn State. That program is a little bit like studying abroad, but instead of studying abroad and going and partying in Paris or something, you go and you study math really, really intensely at Penn State. And I did that. And it's a lot like sort of being in grad school for math, but just for one semester. And I kind of did that to test out whether I would like to go and get a PhD in pure math. And after doing that, I actually decided that I didn't want to. Not because I didn't enjoy it and not because I didn't do well, but just because I decided when I was there, all of the grad students that we met, and we had a lot of interactions with them, they said that if you want to get a PhD in math, you should love it so much that you're ready to, be really poor and just only do math for 7 years. And I wasn't quite ready to do that. I was still a little bit more interested in the ways that people teach and learn math. And the questions of pure math, those interesting research questions that we had been looking at both in my REU and in the MASS program, those questions weren't ultimately as compelling to me as the questions of how people teach and learn math. That is why some people understand math and some people don't understand math, or why do we teach one thing in one way and one thing in a different way, and why do we do these things, and why do some people learn this really well and other people don't learn it really well. And those questions were the ones that motivated me more than those really the questions that were really specifically about pure mathematics. So ultimately, I decided to step away from pure mathematics and go into mathematics education. First, I became a teacher. I got a master's degree while I was a teacher. I got a master's degree and then eventually a PhD from Columbia University in New York. At the same time that I did that, I also taught, I taught 8th grade in the Bronx at the same time that I was doing that. So I have experience in actually teaching in the classroom. But at the same time I was getting my master's degree and my PhD from Columbia University. Both of those degrees are in mathematics education. So I focused on teaching and learning math rather than on pure math like I kind of wanted to, didn't want to when I was an undergrad. Teachers College is the graduate school of education at Columbia, so that's where I did most of my work at Columbia University. Before I came to Cleveland State, I spent a couple of years teaching at Fontbonne University in St. Louis, Missouri. There I had a very similar position to the position that I have here, but I didn't have a lot of time there to do the research that I'm doing here. My position there had me teaching a very heavy load, and so I'm excited to be here where I get to do a lot of research as well as teaching. I began at Cleveland State in 2015, and I'm very excited to be here. I really enjoy it, and I enjoy working with students on their senior projects, which is what I'm going to talk to you about for the rest of this talk. So some of you may know me from functions and modeling probably. That is probably the most likely place that you may have had me. And if you did have me for that course, I hope that it was an interesting course. And you may even get your senior project from a topic that we explored a little bit in that course. You could potentially explore a topic from that course more deeply as a senior project. Okay. So in terms of research interests, I'm typically mostly interested in mathematics education. My dissertation research was in trigonometry education, and that's something that I continue to be interested in. I've developed a curriculum in trigonometry education that's in use in high schools today. Teachers are using that curriculum to better help students make connections between SOHCAHTOA triangle type of trigonometry and the unit circle type of trigonometry that comes later. So they use this curriculum to sort of bridge those two understandings of trigonometry and help students make the understandings come together in a more natural way. I'm also interested in the history of mathematics education. So one of the things that has always interested me about math education is how we got to where we are today. It's always been a question of mine that hasn't always made sense to me, is why do we do things the way we do them? And if you look to education, a lot of that is based on what has happened before. There have been, in education, many laws have been passed, many sets of standards have been issued. In the case of trigonometry education, there's a very interesting history. In fact, up until about 150 years ago, we used to teach circle trigonometry before we taught triangle trigonometry, and then eventually those things were flipped around for some weird reasons that happened about 150 years ago, mostly because at the time students were only using trigonometry for land surveying and navigation, and it was kind of easier to just skip ahead to that triangle trigonometry, solve those triangles, and you didn't really need that circle trigonometry. But then along came calculus. We need that unit circle trigonometry again, and now everybody's a little bit confused by trig. So now we kind of wish we could go back in time, undo that history, and start teaching trig the way that we taught it 150 years ago. So the history of trig can give us some important context to why we teach trig the way we do today. So history of mathematics education is an important piece of my research to help us understand why we do the things that we do today. Another piece of my research is STEM education and interventions. A lot of what we do in our mathematics department today is try to figure out how we can better help students get through STEM degrees that they would like to pursue. We have a lot of students at Cleveland State who want to become engineers or scientists, and for whatever reason they may not be as successful in those STEM degrees, as they would like to be, and we are trying to figure out what we can do to support those students in their STEM fields. Operation STEM is one of the many programs that we have in place to try to help students successfully complete STEM degrees, and I've been doing a lot of research on Operation STEM to try to figure out if it's working and how it's working, in what ways it's working, and how can we make it work better. So in that light, I've been doing a lot of analysis of educational data, some from UTeach, some from Operation STEM, some from other sources, to see not only have we been implementing these programs, but in addition to implementing the programs, we have to figure out how they're working, what's working about them, and how we can make them continue to work and work better in the future, so that we can continue the successes and mitigate the problems with these programs, and continue to build on their successes as we move forward as a university. And most of these programs are funded by grants, so we have to figure out how we can move forward, either continuing with the grant, or after the grant is over, how can we move forward with the program without the grant funding. So these are pieces of educational research that I work on. I'm also interested, moving in a different direction entirely. I'm interested in sort of puzzles and games in math and how those work. I'm interested in that partly because of research dating back all the way to my REU. My REU research was on a puzzle in math. And I'm also interested in puzzles and games because of how they relate to mathematics education and how we can use them to interest students in mathematics. So if that's an area of research, I would be interested in doing that with a student for a senior project. I'm also interested in going into more depth into a topic from functions and modeling. There's a number of topics in functions and modeling that could be explored in great depth for a senior project, and that's a fertile ground for research. So for this talk, I would like to go into great depth into one Operation STEM related research project that a student worked on with me, so that we can explore what one such project might look like. Obviously, your project, if you were to work with me, wouldn't look exactly like this. Maybe it would look nothing like this, but this will give you some idea of what a research project in mathematics education could look like. So this project was done by Kristen Schuler in spring of 2016. To give a little bit of background, Kristen Schuler was one of the very first SPTs, or STEM peer teachers in Operation STEM. So she had a long history with the Operation STEM program, and she was well suited to do this senior project because she knew a lot about Operation STEM. However, other people could, learn the things that she knew. They could learn the background that she was already aware of. But especially people who have been SPTs or who have been involved in Operation STEM are well suited to do a project involving Operation STEM because they know a lot about the program and it helps them understand what they're working with. The big question that Kristen wanted to ask is whether Operation STEM improves outcomes for minority and non-minority students at the same rate. So we knew that Operation STEM one of its main goals was to help minority students achieve in STEM at a better rate than they had been. We knew that minority students are underrepresented in STEM fields, and one of the big goals is to make Operation STEM, for Operation STEM to help students achieve at the same rates as non-minority students, and we wanted to see if Operation STEM is actually doing that. So that was the big question. This required us to request data from the Office of Institutional Research, and then we limited the study to pre-calculus 1 and 2. So you can never really do the research on the biggest question that you have. You have to end up limiting your study to something smaller than your biggest question. She ended up considering pre-Operation STEM data for minority and non-minority students. And then she considered post-Operation STEM data for minority and non-minority students. So she was able to look at several years from before Operation STEM started and then several years from after Operation STEM started. And then she was able to look at minority students and non-minority students and compare those groups before Operation STEM and after Operation STEM in Pre-Calc 1 and Pre-Calc 2. Okay, so taking a look at these results, we have a overall, so you can see this table, just to give the highlights though, pre-Operation STEM, we had a pass rate of overall, this is not looking at minority and non-minority breakdown yet, but just overall, we had a pass rate of 59.6% pre-Operation STEM, so about 60%, which is fairly dismal. Post-Operation STEM, the pass rate is 69.9%, so close to 70% pass rate after Operation STEM. So the relative increase, so on the face of it, that looks like a 10% increase, but it's important in this case because we're going to be looking at two different groups, minority students and non-minority students, we need to look at the relative increase. So the relative increase, and perhaps this should be obvious, but I'll go ahead and explain it just to make sure we're all on the same page about what that relative increase is. So the relative increase is the percent of increase compared to the original. So that 17.2% is coming from the pass rate, so it's the difference between those pass rates divided by that original pass rate as a percentage. So that's where that relative increase is coming from. So that's 17.2%. And so that's where that number is coming from. So that's the increase divided by the original pass rate. And we're going to continue to calculate relative increases. And the reason for that is going to become obvious in the next slide. So looking at, or maybe 2 slides down from now. So looking at the next row down, for Pre-Calculus 2, we have the original pass rate before Operation STEM was 64.6%, and after Operation STEM we have 79% pass rate, and the relative increase there is 22.4%. Okay, so Operation STEM, as you can see, definitely was increasing the pass rates for everybody. Now we're going to break it down by minority and non-minority students. I'm going to first explain, though, how she looked at, in addition to looking at the pass rate, she also looked at mean grades. So she also, in addition to looking at pass rates, she also looked at the mean grade and their standard deviation. So she turned grades into grade points. So A becomes 4.0, A minus becomes 3.7, a B plus becomes a 3.4 or a 3.3, I think, and A or B becomes a 3.0, and so on. So grades become grade points, and the mean grade pre-Operation STEM was 1.97 with a standard deviation of 1.60. The post-Operation STEM mean grade was 2.34 with a standard deviation of 1.51, so that was also improved. In Pre-Calc 2, the mean grade was 2.16 pre-Operation STEM with a standard deviation of 1.58. Post-Operation STEM, it was 2.57 with a standard deviation of 1.37. Okay, and you can see also that the numbers in all these cases are not exactly the same, but they're sizable enough that they're good size numbers and they're fairly comparable. Okay, so let's move on. Now, if we look at the results, so there's one more piece of this that she broke down, and that is the results of Operation STEM scholars versus others. So to briefly explain, if you're not familiar with the Operation STEM program, there are certain students who go to a special summer institute program before the school year starts. They receive stipends throughout the year. They receive special mentoring. They go to special advising sessions. They go to special cohort group sessions. They receive college skills workshops and all sorts of other activities throughout the year. So these students are known as Operation STEM scholars, and they are the benefits of all the program treatments in place because of the grant. So those students are sort of these very special group of students. They're receiving a whole lot of special, we would call them in sort of research, we would call them treatments. They're receiving a whole lot of support. And this is a group of about 40 pre-calculus students every year. And these pre-calculus students, they are, in addition to that, all of the pre-calculus students, not just the Operation STEM students, but every pre-calculus student is receiving additional mandatory supplemental instruction sessions called SPT sessions that are in addition to their typical pre-calculus class every single day. So every single day that they have pre-calc, they have an additional pre-calculus SPT session that's the same length approximately as their regular pre-calculus class. So all pre-calculus students are getting extra pre-calculus instruction because of Operation STEM. But some Operation STEM scholars are getting a whole bunch of other stuff. So we have to break down Operation STEM scholars as a separate group because they're receiving a whole bunch of other stuff, a whole bunch of extra support that other students aren't receiving. So Operation STEM scholars versus other people are two different groups. So Operation STEM scholars, their mean grade was 2.66 versus others who had 2.27, and their pass rate was 80% in Pre-Calc 1 versus 67.6%. In Pre-Calc 2, their pass rate was 82.9%, and their mean grade was 2.89. And the non-Operation STEM scholars, their pass rate was 78.4%, while their mean grade was 2.51%. So you can see that Operation STEM scholars are doing really well, even compared with the non-Operation STEM scholars who were already doing quite a bit better than pre-Operation STEM, where nobody was getting any additional supplemental instruction or anything. So even though just the supplemental instruction has improved, everybody's grades, being an Operation STEM scholar improves your grades even more. So that's exciting because it shows us that our program is working, but we'll see how Kristen breaks down things even further with minority and non-minority students next. Okay, so now we're going to break down minority versus non-minority students. And you'll see that in the top row, we have white and Asian students. And then in the bottom row, we have underrepresented minority students. So just as a bit of background, Kristen breaks down white and Asian students versus underrepresented minority students. And the reason for that is that in STEM fields, Asian students, even though they're an underrepresented minority in our country, they're not an underrepresented minority in STEM fields. In fact, they tend to be an overrepresented minority in STEM fields, and they don't tend to do poorly in STEM, they tend to do really well in STEM. So for the purposes of this study, Asian students can be grouped with white students because they tend to do well in STEM. Okay, so pre-Operation STEM, if you just look at the pre-Operation STEM for both groups for now, so pre-Operation STEM, white and Asian students were passing at a rate of 67.2%, and pre-Operation STEM underrepresented minority students were passing at a rate of 41.4%. This is all for pre-calculus 1. So that's a pretty dismal result. That's a really depressing reality, and it's certainly a sobering fact. But it is what it is. What we can look at now is what happened relatively to the increase, and this is why we need to look at the relative increase. Because the statistics are so different in the beginning, we can't just look at how much their pass rates increase. We need to look at how much they increased relative to what they were. Because the pass rates are so different to begin with, we need to look at how much they increased relative to what they were in the beginning. So post-Operation STEM, the pass rate for white and Asian students is 81%, while the pass rates for underrepresented minority students is 56%. So the relative increase there is 20.6% for white and Asian students, while it's 35.3% for underrepresented minority students. So that is actually very encouraging. It shows us that our Operation STEM program is helping underrepresented minority students maybe even more than it's helping white and Asian students. That is, it's kind of helping to level the playing field. That's very encouraging. And you can see similar things happening with the mean grades as well. Okay, so let's move on to pre-calculus 2 now. So in pre-calculus 2, a similar thing is happening, although the relative increases here are closer together. So in pre-calculus 2, the pass rates for white and Asian students were 66.4% before Operation STEM, and they're 80.2% after Operation STEM, which is a relative increase of 20.8%. After Operation STEM, they are 60.5% and 74.5%, which is not as big of a difference. So you can see that once people move on from Pre-Calc 1 to Pre-Calc 2, things change quite a bit. And we don't know exactly why that is. From anecdotal evidence, we can suggest that Pre-Calc 1 is quite a filter sort of for students. It really tests the waters for people. A lot of people tend to choose whether they're going to be a STEM major, depending on whether they pass or fail Pre-Calc 1. That's just sort of an anecdote. Anyway, so in Pre-Calc 2, the difference isn't as big either in the original pass rate or in the difference of the relative increase. But the difference in the pass rate is, so it's 60.5% before and then 74.5% after for underrepresented minorities, which is a relative increase of 23.0%. Now these numbers are pretty small for the underrepresented minority students, so when we go to statistical significance, we'll have to keep that in mind, that those numbers are going to be fairly small. So looking at these results, in both cases, we performed a two-way ANOVA. So an ANOVA is an analysis of variation. You'll probably remember from your statistics course. And that showed that the difference between pre- and post-Operation STEM is a statistically significant difference, and that the difference between minority and non-minority students is significant, but the interaction between them is not significant. So, translating that into people language, that means that Operation STEM is making a difference, and it also means that there is a difference between minority and non-minority students, but that the rising tide of Operation STEM is lifting both of those boats more or less equally. It's statistically equal that those boats are being lifted up, right? So as that rising tide is moving up, the boats are being lifted statistically equally. So that was the result, and an encouraging one. It shows us that our program is doing a good job. We can see that the results are showing that those minority students are actually being helped maybe a little bit more relatively to the non-minority students, but that they're statistically significantly, or they're statistically equal, and that's good. We want to be helping, we want to be helping everybody equally. So if you were interested in doing educational research, there's some things you ought to know. One thing you ought to know is that you don't get the data in a nice format. When you're in a statistics class, you typically get the problem in a really nice package. You get the data in the way that you need the data. That's not what happens in educational research. You typically get the data in a really messy way. You may not get exactly the data you want, and you have to kind of figure out how to work with it. So that's a big part of it, is just getting it into the format you need. Also, nobody tells you what tests to use or which data to compare. So there's a lot of figuring out what exactly needs to be done. A lot of the work is just looking at what data you have and how you can best use the data to answer the question. And typically you can't answer the biggest questions that interest you. You might have to go with answering a smaller related question rather than answering the really big question that's the most interesting question to you. That's just the nature of educational research. We're interested in really big questions, and we don't always get to answer them. So you get to just answer the questions that you have data that answer. Unfortunately, that's kind of the way it works. But you do get ideas about what data you would like to gather in the future, and that's something that happens in educational research over and over again, is one question leads to a small answer, which leads us to gather new data, which leads to another question, which leads us to gather new data. So things to know about working with me in general are, so a lot of you that may want to work with me may be future teachers, and that may mean that you're student teaching. I know that a lot of you who are student teaching for whatever reason, have to register for your senior project in the semester that you're student teaching. I get that, but if you are registering for senior project in the semester that you're student teaching, please know that the majority of your senior project has to be completed in a different semester. It just absolutely doesn't work to complete your senior project in the semester that you're student teaching. I don't want it to delay your graduation, and I certainly don't want it to delay you looking for a job, and I don't want it to delay you starting your life. So in order to facilitate that, you really have to complete your senior project and have it most of the way done before you start your student teaching. There's ways that we can work that out, and I'm happy to work that out with you, but it just needs to be something where we arrange it so that you're either working on your senior project before or after student teaching, so that student teaching doesn't get mixed up with senior project so much. Also, I think that even if you're not student teaching, every student benefits from using more than one semester to work on their senior project. One semester in which most of your preparation and research is done, and another semester in which most of the writing is done. This is especially true when we're collecting data, because sometimes it takes a while to get the data, and sometimes we have to get the data once, and then we see that the data isn't the right data, and then we have to get it again. And so that can be a time-consuming process. So keep that in mind as you're working on your, thinking about your project and working on what you might be wanting to do. I often have sources of data available. If you kind of are interested in this sort of thing, but you don't know exactly what you're interested in, I often have things available to me. Some of those, I'll talk about some of those a little bit later. You also may not know what you really need until you begin to analyze the data, so we might have to go back and revise things maybe even more than once, and that's okay. Some data also requires time or special permission to actually obtain. Sometimes we have to get special authorizations depending on what kind of data it is. In the case of Kristen's data, because we were looking at minority and non-minority student status, we had to get special permission from the University Registrar's Office in order to get that data, so that took a little bit of extra time. So it's important to begin that process early so that we can make sure we have plenty of time to do the data analysis so that we're not rushing. Keep in mind that senior projects take time to do well. Plan to work a little bit each week throughout the semester. We will meet frequently so that you make sure you make consistent progress. So here's some possible data sources. If you're interested in education, Operation STEM data is a place where we have a lot of data that needs to be analyzed. We also have some data in the mathematics department that can be analyzed. UTeach sometimes has data that we can find or that we can get from UTeach. That also takes a little bit of time to request. But if you're a part of the UTeach program and you're interested in finding out more about how they do things, or if you have a question about UTeach that you would be interested in researching, that's an interesting possibility. One of my students went to a UTeach conference and presented his findings, which was pretty cool. There's also a National Center for Education Statistics where data can be downloaded. That data is very raw and often a little bit difficult to wade through, but it does have very interesting data. There's a schools and staffing survey that surveys a bunch of teachers and gives a lot of data that's interesting about teacher retention and what teachers think about being teachers. That's very interesting data as well. Also, if you were interested in a different type of project, sort of a functions and modeling type of project, one possible source for that would be the National Oceanic and Atmospheric Administration, NOAA, has weather data that you can download, and you can model all different types of functions related to the weather, and that's a pretty cool project as well. So thank you very much for your time, and I hope to work with you sometime in the future.